Hey guys, in this video we are going to solve the trig equation you see on the screen right now. In the first layer we're just going to solve for tan theta. In the second layer, if we can do it without using a calculator for now, we will solve all the way for theta. For videos explaining how to solve for theta, you can go ahead and check the playlist, which will be a thumbnail at the end of the video, solving trig equations. But for this one, that's all we're going to get up to. If we could do it on the unit circle in our head without a calculator between 0 and 2 pi, we will. If not, we're just going to leave it at tan theta equals whatever. We'll also be deciding if the ratio we found is appropriate or not and how to determine that. So let's try to make this as quick as possible. All right, if you look at the problem, the first thing you need to do, eyeballs, brain, connect, make a message, and tell yourself, I need to solve this equation. Fundamentally, on the base layer of it, it is in the structure of a polynomial equation. In fact, it's a lot like a classic quadratic trinomial. So like all polynomial equations, unless they're already to the first power, we want to solve by factoring, and we do that after we get the equation equal to 0. We will get this equation equal to 0 by subtracting 15 from both sides. I'm drawing an arrow right now, okay? I will show all the details in some videos. I am not going to treat you like you're in 7th grade for all of the videos. So subtract the 15, subtract. You don't pick it up and put it down. You are not a weightlifter, okay? Minus 15 equals 0. So now what you need to see is that the power here is double the power here, and this has no tan theta, no variable, none of that. So you are in the ax squared plus bx plus c structure. We can solve this with the AC method and or jumping right into it. And if you use AC method, it turns it into grouping. I will do that way first. If you wanted to rewrite this for yourself, I don't think you need to, but some of you may prefer it. 2x to the 4th, I'm just calling x for tangent. I know that on the unit circle, x is cosine. Right now, I'm just placeholder. Minus, technically, that's a 1x squared minus 15 is 0. So we're just a little make-believe, a little abbreviation, okay? AC means you multiply AC. That is 2 times negative 15. That is negative 30. You think to yourself, what multiplies to give me 30? And you make a little list in your head or on your paper, and you see that we have those 4 pairs of factors, and then we get to the bottom of the list, B for bottom, and B is negative 1. Which pair of factors on this list can I use to not only multiply to make negative 30, but can I also use to add or subtract, whatever you want to think of it, to get negative 1? The pair that stands out to me is 5 and 6. I'm not just committing to that one. I'm in fact ruling out the others, because sometimes 2 pairs of numbers are good, but you want to make sure you pick the right one, you know? So negative 30, negative 1, that means if they multiply to be negative, one of the 2 is negative. If they have a negative sum in this situation, the bigger number is negative and the smaller is positive. Those numbers, oh God, please don't be this person. Those numbers are used to split your middle term, and if your middle term has x squared, both of them will get an x squared. No, they're not x. X plus x is not x squared, for crying out loud. X times x is x squared. When you split the middle term, it will have whatever the middle term has. Like terms are what you add. They must also have x squared. I can't believe I have to say this, but I do. 2x to the 4 plus 5x squared minus 6x squared minus 15 is 0. Okay, obviously the x would be tan theta. Now you could factor this by grouping. Remember, when you split your trinomial into a polynomial 4 terms, but kind of, not really because they're like terms, but 4 parts, you're breaking it down into FOIL, first, outer, inner, last, okay? That's why the second way I'm going to show you how to factor this a little faster for anyone who can handle it. That's why we care about those 5 and 6 still, okay? When we're doing the guess and check, kind of jump right to the factors method. Some of you probably subconsciously do it, and some of you will consciously do it. What's the greatest common factor here? X squared. It's not 2x squared. I see that a lot, okay? It's just x squared, so slow down. You should still have that 2 in there. And then think about it. If I still have the 2 in there when I take out the GCF, it's probably 3. But if that's negative, we're going to use negative, negative 3. Take the x squared out front. What's left inside if we divide and divide? 2x squared plus 5. No, it doesn't have an x squared. If it did, they'd be like terms. You'd add them and get 7x squared, and none of that makes sense. If you couldn't add it before, you can't add it later, okay? Take the negative 3 out front. X squared, 2x squared, 2, get over here. 2x squared plus 5. If you don't understand why, please pause and think about it, and, you know. And in fact, you shouldn't just be doing this with me. You should have tried this by yourself. I should have said that. Is that a disclaimer? I don't know. Factor the common factor out front. What common factor, you may ask? And if you are asking that, oh God, do you pay attention at all in school? What are you doing? That is the common factor. Do you see they both have one? I am pulling it in front. Okay? Now, I'm going to marker all over my hands. If I pull 2x squared plus 5 in front, gotta pretend it's not there for a moment. What's left is x squared minus 3. What does this mean? And don't lose your equal 0. I hate when people stop writing equal 0. I find it really annoying. So what I'm gonna do, write it down if you need to write it, pause it if you need to pause. Can't roll this up. So what do we have? 2x squared plus 5, x squared minus 3. So I'm gonna I'm running out of paper, so I'm just jumping over here. Now, I'm going to write down what we had here, okay, this. I'm going to write this down, but with tan. But I'm also going to do it right now. See, oops, come on. I'm going to do it the other way, where you can do it in your brain. If you can't handle this, please fast forward or just la la la. Don't listen. Just do that other method, okay? 2 is prime. Love it. Love a prime number for this. What multiplies to give you 2 tan to the 4th theta? It's going to be with this power, right? Okay. 2 tan squared. Are they both 2 tan squared theta? No, because that would make 4. So this one is just tan squared theta. First times first, does that indeed give you 2 tan to the 4th theta? Yes. Now, last times last needs to give me 15. Still think the same kind of concept we thought before. It's just not 30 at the moment. What multiplies to give you 15? 3 and 5, or 1 and 15. But it really could go lots of different ways, right? Because when you FOIL, think about FOIL, please. Just really think about this. Outer and inner are what made the middle term. So let's report back to AC method. We did AC. You could still do that. 2 times negative 15 is negative 30. Ba, ba, ba. Pick your pair. What's the pair? 5 and negative 6. Okay. That means outer and inner, which combine to make middle, will become 5 and negative 6. If that's got a 2 on it already, 2 times what is, should I make it 5 or should I make it 6? Negative 6. I hope it's obvious to you. If it's not, please stop listening to me right now and just fast forward a smidge. It should be the negative 6. I'm not trying to multiply 2 by a fraction or decimal to get 5. So if I want negative 6, 2 times what? So negative 3. Outer is negative 6 tan squared theta. That will mean the inner will have to be the positive 5 tan squared theta. That means that's plus 5. So look at, that is what we had before. We are so smart. Got it. Can you FOIL this back and get the line above it? Absolutely. And there you go. Amazing. So whatever way you want to factor, that's AC method. I just used x instead of tan to save room on my paper. And this is using your brain. They're both using your brain. But, okay. Now, gotta keep going. Biggest power is 4. We're probably going to have 4 little broken down parts in some way. So let's go from here. Set them all equal to 0. 2 tan squared theta plus 5 equals 0. And the other one, don't write these on top of each other. Write them next to each other and line them up with where you're getting them from. That makes more sense, you know. There's super ambulance or fire trucks in my background if you hear, sorry. Okay, get tan theta alone. 2 example videos ago, if you saw this particular cluster of videos, we saw one that looked like this-ish in the beginning. Subtract 5 to the other side. 2 tan squared theta equals negative 5. Divide by 2. Tan squared theta equals negative 5 over 2. Take the square root of both sides. You need to put plus minus tan theta equals. Okay. So, plus, I guess I'll show it. Plus minus the square root of negative 5 over 2. Right away, we could just say no solution. You can't do the square root of a negative. Let's just practice our imaginary numbers. Plus minus, when you have the square root of a negative, right off the bat, you can pull out an I, and the negative is no longer inside. Comprende? Now, the square root of a fraction is just the square root of the top, square root of the bottom. Not allowed to have radical on bottom. We must rationalize denominator. Plus, minus, rad 5 times rad 2, we have I radical 10 over radical 2 times radical 2 is 2. So that's how you would solve it algebraically. Deep down, imaginary, obviously, we can't solve for theta. Okay, you cannot build a triangle out of that nonsense. Next one, tan squared theta equals 3. I'm saying the next line. Tan squared theta minus 3 equals 0. Add 3 to the other side. Tan squared theta is 3. Square root of both sides. Include your plus minus. Yay for positive numbers. So tan theta equals plus minus radical 3. And that is so cute and beautiful. We love this because that's not only, finito, it's also doable. Because why? Why do you know it's doable? Let's go over. I'm going over here. How do I know it's appropriate? Okay, is it good? Tan, the rule is opposite over adjacent. Hypotenuse is not there. That means anything could be over anything. It could be a bazillion over 1. It does not matter because the hypotenuse is the only one that's locked in stone. Has to be the biggest side. Okay, so number-wise, it's fine. Is it a ratio? Sure, it's root 3 over 1. Top is technically bigger, right? And why is it double good? So it is appropriate. Check. Why is it double great? Because root 3 is one of the ratios that we know for tangent on the unit circle. So we're going to get, if we were solving between 0 and 2 pi, we're going to get 4 answers because it's positive in 2 quadrants, negative in 2 quadrants. So where in radians does tangent equal radical 3? Radical 3 is at the pi over 3's. Pi over 3, tall and skinny like a tree. Pi over 3, so tan is positive here and here. I'm not going to write these down, so you better be listening. So where is tangent equal to positive radical 3? That would be pi over 3 and at 4 pi over 3. Next, tan equals negative root 3 between 0 and 2 pi. Tan is negative in quadrant 2 and tan is negative in quadrant 4. So what's this one right here? That tall and skinny like a triangle, 2 pi over 3. And this one is 5 pi over 3. So you got 4 angles that happen to be correct between 0 and 2 pi. How many answers are there in general? An infinite. Every single angle, bloop, 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 that overlaps this, whether positive or negative. And there you have it, okay? If you need help with AC method on the factoring playlist, actually on the solving trig equation playlist that's going to be on the end anyway, there's actually factoring lesson little videos that I actually did with other classes before this particular unit, saying getting ready to solve trig equations, how to factor blah blah blah. There's, just scroll, you'll find it. I think it's like a pink purpley tie-dye background and it's white font. Maybe. Thumbs up if you're happy and you know it. Thumbs down if you're just a grumpy human right now. Good luck, study, be smart, be nice to someone. Bye.